Well, I'm gonna start the lecture. Um, so as the announcement says right here, today we'll be talking about more functions that are using either arrays or pass by reference parameters. We'll definitely take a look at binary search as an iterative algorithm. And then the second exam is scheduled next Wednesday, and I have attached an exam from last semester. This is exam two from spring 2025. So, I think it would be great if people have time to take a look at it before the class on Wednesday. So this way, when people have questions, they can ask me before I go ahead and go over the exam itself. The scope of the exam from last semester only covers arrays but not functions. So I probably will keep the same scope, which means that all the stuff of functions will not be in the second exam. So do you have any question? Nope. Okay. All right. Cool. All right. So I do recommend, people who are either watching the video or in class to go ahead and try out the homework. I mean, not the homework, but the test for exam two. They should all be pretty easy to answer at this point of time. Um, and these are not inside of the context of functions, which is okay, because we simply have to use the older, simpler way of tracking variables instead of using the new way of whether of having to allocate columns. So that's that for exam two. Back to today's topic. So I wrote a program to illustrate the concept for today, so that's what I will be using. We'll drag the box over here, make it larger so that we can see a little bit better because I'm intending to kind of use the editor inside this command line interface. Yeah. Um, so so in Windows this is called CMD. Um, but CMD or command in Windows does not come with many of the tools that I use. So that's not, so you may not be able to get the same kind of result. Um, in Windows, you can install code blocks or a VS Code, so they can give you a more graphical user interface. Um, they're supposed to be easier to use, but not to me. You can also use online GDB, and there's another one called Online IDE, I believe. So those are web-based resources, which is kind of nice because you can sign in from any computer. So I think Online GDB we have looked at already, but the other one is Online IDE, if I remember correctly, but I'm not 100% sure. Nope, that is not it. So it's online something, but it's not IDE. Online games IDE. Oh, it's online-ide.com. Yep. So this is another one that you can use. Um, but it is capable of Python and other languages like C++. So we can use it today. I mean, today's class, we can try this out. Okay. So that's what we'll do. We're gonna try this out. So we get rid of this, and then we replace it with the program that I intend to illustrate in today's class. So let me go back to this folder. It's called binsearch.cpp. So I'll copy that to the clipboard and then copy that into um, online-ide.com. Xclip dash select clip. There we go. Switch back, paste. There we go. All right, excellent. So we'll see how well this goes. I think it works about the same way. So we'll see. Um, Hello. Good morning. All right, so this is binary search as a function. So we talked about the binary search algorithm, and we have traced through the binary search algorithm, in class already. So this is what it looks like. It has got three parameters. So once again, parameters are ways for the caller in order to communicate with the function so that, it knows what array we're supposed to search in, the number of elements in the array, and also what value we're looking for in the array. So those are the parameters. It tells the function what it needs in order to get the job done. And then when the function is done, in this case, it goes back to main, and then all we are doing is to store the return value of bin search into result. So this is something that we should know how to do already based on what we have already talked about last week. So the only thing that is new is to look at bin search not as a standalone algorithm, like before in one of the homework assignments, but this time we look at it as a function. All right. So we'll go ahead, and there are a few things I do want to illustrate, as we go through this algorithm. So we're gonna put a breakpoint on line 22 or line 21, sorry. So let me see how to put a breakpoint here. Um, Reading mode. Nope, that's not what I want. So how do we set a breakpoint? Right click. Nope, that does not help. Usually it is a putting a you're clicking on the left hand side, so that does not seem to work. You can run it, but running it is not going to do us any good because I have to debug it. So it looks like this may not be the best way to m- to move ahead because I need a debugger. I cannot just run it. All right, so do we see debugger? Mm, I don't see it here. Okay, this is a split screen, horizontal layout. Mm, it doesn't give me an option of debugging. Yeah. All right. Well, I'm gonna go back to my old tool. Okay, but you guys can use whatever tool you want. So let me just kind of point out the two tools you can use for this purpose, for debugging, but easier to use compared to the command line interface that I show you guys. So one is called code blocks. So it's just code blocks, sometimes spelled with two words, sometimes one, because it's supposed to use colon colon in between. So code blocks is a fairly kind of archaic, old program, for this purpose. It has not really been updated for a long time, I think. Okay, so you can go to downloads and go to binary release. Oh, okay, it's fairly recent. Okay, I wouldn't say it's ancient, but you can get it on Windows, which is great. Okay, it only lists up to Windows 10, but it's gonna work on Windows 11 as well. It'll give you a user interface that's pretty friendly to use, and you can kind of explore how to use it. The other one is VS Code or Visual. What is the S? Studio, that's it. Visual Studio, your code. It's free from Microsoft. You can also use that also to kind of run your C programs. Huh? Yeah, Visual Studio. Yeah, so you can look up VS Code. So sometimes spelled with a space in between, sometimes not. But if you just look at VS Code, with a space in between, the first link is Visual Studio Code. And it is available for free as well. Okay, so you can use either one. I personally do not use either, because I really do not like IDEs. They're more complicated and things need to be from my perspective. Yep. So that's just me. Most people do not like to use command line tools, and I just prefer to use command line tools. So let me switch back to the command line tool, just because that's what I'm used to. All right, so we'll take a look at bin search as a C++ program, okay? And we should recognize a good portion of it, like the first portion, I would say from lines 4 all the way to line 13, that should be something that we're familiar with already because that's just good old binary search. Okay. Except I now encapsulate the algorithm into a function just so that I can call the function anywhere I need from anywhere where I need to find something. And then we move on to line 17, which is main. Line 19 is how we basically create an array that is also initialized at the same time. So this time we have, if I count correctly, 7 elements. 1, 5, 10, 11, 14, 18, 21. Those are basically the elements inside the array called values. That is a quote unquote local variable in main. And then we have another local variable called the result here, and then we just call the function, whatever it returns, we store back into result. So do we have any questions about the algorithm itself? No questions? No questions? All right, cool. All right, so if there are no questions about the algorithm itself, I am going to, I'm thinking how to do this because I want to show you the debugging session, but I also want to show you the code, at the same time. Not in a way that makes it kind of difficult to read. So I will try something like this. Okay, I'm gonna have to shrink the code just a little bit. Is it still readable to you? In the back? Yep. Okay. All right. So I'm gonna put it on the side here, and then I'll start a new terminal. So it's easier to look at the debugging session and also to look at the source code at the same time because there are a few things I want to illustrate that can benefit from this side-by-side arrangement. So there we go. I think we can bump this up by maybe one level. Yeah, that makes it a little bit easier. And then on this side, kind of this one can be a lot larger. It's okay. All right, so go to this folder. I believe I have it already compiled. It doesn't hurt to recompile. Okay, so I'm just recompiling the bin search program into an executable. So this way we can run it. There we go. And then we GDB, bin search. The GDB stands for GNU debugger. It's basically a command line tool. It looks really complicated, difficult to use, but it really is the back end of um, code blocks, VS Code, and many other tools. So knowing how to use GDB, eventually will be useful, but you guys don't have to use it in this class, okay? But there are a few things I do want to illustrate. The first thing is I'm going to stop on line 21, okay? So we'll put a breakpoint on line 21 and then just run the program up to that point. Okay, so we are now on line 21. We can tell that we are on line 21 because we are now at the breakpoint, and it says we are on line 21 here. So there are two things I want to do. Okay, the first one is I can print values, and it basically just shows you how it is initialized. Okay, so it's not a really important thing, because that's exactly how we initialize it. And you can also say, okay, what about, a particular element? Let's say element 2. So what do you think is the value of element 2 of values? That is correct. It is 10, not the 5, because we count from 0. Okay, so you are absolutely correct that 10 is the value of element 2. So it is confusing if I use the second element because when we count using first, second, and so on, the second element most people would believe has a value of 5 because that's how we count because we don't usually count the 0th element, right? So that's why I don't call these first and second. I just call element 0, element 1, element 2, and so on. So that way the index is telling us which element we are referring to when we look at an array. Are we okay? All right, cool. Okay, so if I print it, it's just 10, not a big deal. The dollar sign, is I think I know it looks confusing, but it gives me a way to refer back to a print result from before without having to type the entire thing. So that's just why the $2 is here. All right. So, but there's one little thing that I want to show you, which is, at this point, we don't really know that operator because we haven't really talked about it. So it is called the ampersand or the address of operator. So in this case, if I say what is the address of values bracket zero, which is element zero of values, it gives you some mumbo jumbo hexadecimal number thingy. Okay, so we don't have to really pay too much attention to this particular value, other than it ends with DD40. Okay, so I'm just going to write it on the whiteboard here, just so that we can remember it is DD40. In a very strange way, okay, strange in this class, okay, that identifies the column of where element zero of values is in the trace. So in our trace, we use columns, right? In a spreadsheet. So this would be typically the way I put it is this is going to be in column C or something like that, okay? But inside the computer, it doesn't have columns. It doesn't designate those things as columns. They're addresses, okay? So as it turns out, DD40 is where element zero of value is residing. All right, okay? So we just write it down here. And then we single step, okay? When we single step, it means we are going into the function and we are stopping on line 4 of the function, okay? So single step, oh, wrong side. There we go. All right, so now we're in the function. We know we're in the function because it says right here that we are on line 4 of the source code, and line 4 is right here. So we are right on this line here, or the execution point is right there. So I want to show you one thing, okay? And that thing is, let me see what is A. What is A? A is a parameter. It is, the array parameter where I use values to pass to it. So are we seeing the association between values of main on line 21 as an argument that is matching parameter A of the function definition on line 2? Are we making that match? They're both the first. Okay, so values on line 21 is known as an argument. So whatever you put in the parentheses when you have a function call, they are called arguments. So values is the first argument, 7 is the second argument, and 14 it would be our third argument. Okay, so all of those arguments, basically they match the parameters when we look at the definition of a function. So line 2 is the first line of the definition of the function bin search. So when we make a function call, the first argument goes to the first parameter, the second argument goes to the second parameter, and then the third argument would go to the third parameter. Are we doing okay so far? Okay. So we'll go ahead and take a look at the easy one first. So we look at n and it is 7. That's not really surprising because this is our second argument and this is our second parameter. And they're passed by value. So we'll take a look at k. Okay, k is 14. Okay, hardly surprising also. But what about a? Okay, remember in the class I said, if you pass an array by as a parameter, all you're passing is where to find the first column of the array. Do you remember that? Okay, so when we print here A, let's see what we're gonna get. Oh, is that what you expected? Yeah, because when we look at the address of element 0 of array, it is at a critical address of DD40. It is basically a very strange way of designating a column. Okay, just think of this as a really strange column name. Okay, so we can also see that A as a parameter is referencing the same place. It's basically saying, oh, I am not an array. I just know where to find the first column of the array, which is over there. Is that okay? So, last week when we talked about this, I did not show you using a debugger. I was just kind of talking like, this is a reference to in a column, or that column being the first column of the entire array. But today in the debugger, we can actually see that, in action. So that's kind of the purpose of me doing just this part here. All right. So when we run the code here, we can run it inside the debugger. We can actually track through all these lines and basically look at how B and D are going to change over time. But instead of doing that using a debugger, I'm just going to do it in the trace. Okay, do it the old-fashioned way that we usually do things, which is in the trace. All right, so that's the first thing that we're going to do. I suspect it would take about half the class, of the half of the class time, maybe a little less, just to do this part. Okay, so before we get into the hand tracing, do we have any questions about what we are seeing on screen at this point? No questions? Okay, all right. So if there are no questions, then this window does not really serve any purpose anymore. I'm going to close the window and then I'll do the usual thing. You'll copy and paste this code and then we'll start to trace it. But before we do that, I'm going to take out some of the lines of comments. They are just reminders for me to go through what we just went through. Okay, so they're not really useful other than just serving as a reminder. So I'm going to shrink this just one more step so that it does not take up as much space. So we'll do a usual snapshot of the screen like so that we can paste it into um, the trace itself. There we go. But also so that we can display it. So we're going to show it display it first. Okay, always on top. Put it on this side. And then we go back to our shared folder, create a new spreadsheet for today. And by the way, have you guys used the spreadsheet at all? Have you downloaded the spreadsheet and added all your own comments and whatnot? Okay, was it helpful? Cool, excellent. Mm-hmm. Yep. Yep, that's good. That's a very good use of the spreadsheet. And did you print it out and then add your own comments, or did you add your own comment to the file itself? To the file? Cool. Can you print it out with your comments on it? I think it. I think you can. I think you can, but it would only serve. Let's give it a try here. All right, so we're going to give it a try. We'll just have comments and line number. And then in the comments, I am going to, okay, let me first change the name here. 2025. Today is 1103. There we go. So I'm going to add a insert. I think note is the one that we want to use. So we're just going to insert a note of this is a column to evaluate conditions. Okay, that's it. So now we go to Control P, print it out. Okay, so for now, I need this to be out of here, but I think there's a way to include that. So current sheet, that is correct. Paper size, portrait mode or not. Okay, none of that is super important. Formatting. Okay, there we go. Um, Show notes. Okay, there we go. So the notes is actually shown on the second page. So when you flip to the second page, it says that there's a little one here, and it refers back to this little one here. So it does print out, but it won't print right next to it because otherwise the column would look kind of all funky. So it will only kind of give you a reference of one, and then you have to look up, the footnote to find out what that one means. Okay, so I just want to make sure it prints out because in the exam you can only bring in things that are on paper. So that means that's why I'm double checking. Yeah. Yep. All right. So now that we know that works, excellent. Cool. All righty. So now we are ready to do the trace. Um, when we are tracing, I'm going to maximize the browser window just so that it shows, I have a little bit more space here. All right, so we're gonna start the execution on line 16. That's where main starts, not really useful by itself. And then we move on to line 17. Line 17 has got a lot of stuff to do because it has to allocate the columns for values, which is an array. So I'm gonna just use values over here, and then I will also make it very clear that it has 7 elements. So it has 4, 5, and 6. There we go. So we mark these and then kind of Make them not as wide, okay, but that's not the width that I really want. Maybe about this much. There we go. So now we stick all the values in, okay? So we have 1, 5, 10, 11, 14, 18, and 21 here. So that's basically what line 17 is doing is it's just allocating the columns for values. But as a single variable, when you look at values as a single thing, it does use all 7 columns. So I'm going to go to Format and go to Merge Cell, just so that when we look at the name values, we understand that values encompasses all 7 columns from column C all the way to column I. But if you use the square bracket notation, you can single out a particular column. Okay, so now we move on to line 18. Line 18 says, oh, we also have a Boolean variable called result, but since it is not initialized, it has an unknown value to begin with, which means it can be true or false, but we don't know which way it is. All right, so now we move on to line 19. Line 19 ultimately is a assignment operation, but I cannot do the assignment unless the right-hand side is resolved because the right-hand side of line 19 is a function call. So that means I kind of have to do the function call first. So this is our first time going to line 19, and I have to make a function call that is going to return back to line 19. So I need return info just so that I know, oh, by the way, we have to get back to line 19. But when we get back, the right-hand side of the assignment would be done already. So we would have a single value to change the left-hand side. So that's why that portion is replaced by a single question mark. But whenever you call a function, you have to make sure that you allocate columns for all of the parameters. So we have 3 parameters in this case. So let's name the parameters first. So we have parameter A, parameter N, and also parameter K. Those are all listed here, A, N, and K all the way here. So now we will handle the 2 that are easy because parameter N and parameter K are passed by value. So that means whatever argument matching the same position, which would be 7 and 14, would be their initial value to begin with. So we have 7 for N and 14 for K. So those 2 are the easy ones. Okay, so let me uh, shrink those 2 columns so they don't take up too much space like so. There we go. So A is the one that is kind of funky, but we know it's not funky because we have done this many times last Monday and also last Wednesday already. So because we are passing an array, which is values from main's perspective, to a parameter that is also an array. So we know that this is really just a reference to the first column of the array that we specify as the argument, okay, which is values. So you look up values and you ask, okay, what is the first column of values? It's column C, okay? So as a parameter, A is really just saying that, okay? It's just saying, okay, I'm a reference to column C. That's all it does, okay? So that ends, the passing of the parameters, setting up the return info. So now we are ready to go into the function that is being called, in this case, bin search. It starts on line 1. Line 1 doesn't really do a single thing. Then we have line 2. Line 2 says, okay, we need a few local variables. So one is B, one is E, and one is M. They're all unknown at this point. So we use question marks to indicate that, yeah, we have 3 more variables, but they have unknown values at this point. So now we just kind of shrink the columns a little bit. I hope the whole thing would still show on the screen. Yep, we barely have enough space, which is good. Okay. So now we move on to line 3. So from line 3 all the way to line 12, that's just basic binary search that we have already done as a homework. Okay, so that should be not a whole lot of big surprises here, because in the homework, I think we were comparing linear search to binary search. So, and I have graded that one already too. So you guys might have your score. You can look at your score. Um, for that one. All right, so we're moving on to line 3. It says b equals to 0. Okay, fine. B equals to 0. And it says line line 4. is changing E to be n minus 1. N is 7. 7 minus 1 is a 6, so we put a 6 here. And then we get on to line 5. Line 5 is do. I don't track the do statement itself because it really doesn't do a single thing. So we move on to line 6, where we compute the value of m. M is b plus e divided by 2, which is 0 plus 6 divided by 2. 0 plus 6 is a 6. 6 divided by 3 by 2 is a 3. So we stash a 3 over here. And then we move on to line 7. Line 7 is a conditional statement or the beginning of one. So now we go like, okay, so we have a bracket m is less than k. Is that true or not? Okay, so this is where things get a little bit more, slightly more complicated. So the first thing is, okay, I need to know what A is. So we look up the rightmost column that is labeled A. Okay, it just says, let's go to column C. Because what A is an array, but all I can tell you is which column starts the array that we are trying to refer to, which is column C. Okay, so now we see the square bracket. Inside there's an M. So we look up the rightmost column that is labeled M, which is column Q. It has a value of 3. So we are looking at element 3 of the array that starts at column C. Okay, so element 0, element 1, element 2. We can see element 3 is column F. It has a value of 11. So that means the left-hand side of the less than is 11. Then we look up K. Okay, so K is referring to the rightmost column that is labeled K, which is this column, which is N. 11 is less than 14 is true. Okay, so we know this is true. So then we move on to line 8 because that's the then statement of the conditional statement. All it wants to do is to compute m plus 1, which is 4, because m3 plus 1 is 4, and then store that to b. So b is now a 4, and then where do we go? We are we just completed line 8. So where do we go after line 8? Line 12, that is correct. Okay, because this is a conditional statement. As soon as we are done with one of the branches, we go like, we're done with the entire conditional statement. So we move on to line 12. Line 12 is trying to see if we have another iteration because we have to evaluate the conditions. So B is less than or equal to E is true because B is 0, E is 6. Sorry, we just updated. Sorry, B is 4 because we just changed it, but still 4 is less than or equal to 6 is true. But because it's a conjunction, just knowing one side is true does not mean that the whole thing is going to be true. So now we also have to evaluate a bracket m does not equal to k. Well, m has not changed, right? So we are still looking at column F, which has a value of 11. 11 does not equal to 14. It's still true. So we have true and true. So that means the entire expression is true over here. And then we just make this a little bit wider. Okay, there we go. And then we can now go like, okay, since if the while loop condition is true, we have to go back to perform another iteration. So now we go back to line 6. And line 6 says, okay, we have to recompute m. This time it is 4 plus 6, the whole thing divided by 2. So that's 10 divided by 2, which is just 5. Are we still doing okay so far? Okay, cool. So now we go continue to line 7. Line 7 is still evaluating this condition, but m has changed. So now we have to go like, okay, we are still going to look at the array starting at column C, but because m is now 5, we are looking at element 5. Element 5 is column H. It has a value of 18. And 18 and 14, they're not the same, but the most important part is 18 is less than 14 is false. So yeah, go ahead. Hmm. We are not there yet. We never got there because the loop is still going. Yeah, yeah. Because from line 12, we went back to line 6, so we're not on line 13 yet. Yep. All right. So now the question is, since A bracket M is less than K is false on line 7, where do we go now? Line 9, that is correct, because line 9 is the else branch of the outer conditional statement, but by itself, it is also a conditional statement. It is now asking the question of whether A bracket M is greater than K. Now that one is true because A bracket M is still referring to column H, which has a value of 18. 18 is greater than K, which has a value of 14, is true. Okay, so we know the condition on line 9 is true, and then where do we go after that? Well, we go to the then statement corresponding to the if statement on line 9, which is line Line 10, that is correct. Very good. Okay, so we are now on line 10. Line 10 does not really have a very difficult job. All it wants to do is to say, okay, let's subtract 1 from m, and that becomes the new value of e. M currently has a value of 5, so now it has a value of 4. And then we are done with the conditional statement. We just kind of fall through all the way to line 12. B is less than or equal to E is true because they are both 4. Okay, we can see that B, which is column O, has a value of 4. We can see that E, which is column P, also has a value of 4. 4 is less than or equal to 4 is true. Okay, but we also have to check the second condition, which is um, what about A bracket M being different from K? Well, M really has not changed, so we're looking at column H, which has a value of 18, comparing that to column N, which has a value of 14, they are different. Okay, so now we have true and true. So let me write it down, which is true. The conjunction itself is true. So that means, okay, we have to go back to line 6 again. So this time on line 6, we have to compute m as 4 plus 4, which is 8, divided by 2, which makes it also 4. And now we go to line 7. And line 7 asks, A bracket m is less than k. Is it true or not? Well, m is 4, so we're looking at element 4 of the array that starts at column C. It is 14. And then we compare that to k, which is also 14. 14 is less than 14 is false. Okay, so it is false. So that means we go now to line 9, which is asking this question. Well, since we know they're the same, the greater than is also going to be false. So that means, that means we don't have to do a single thing. Neither B nor E is changed in this iteration. Okay, okay, so now we go to line 12, right? We get to line 12, and line 12 is asking, is B less than or equal to E true? Yes, because they are still the same as the previous iteration, because we didn't change either one in this iteration. But M changed. So now when we ask whether M is not the same as K, that is now false. Because M is now 4, we're looking at element 4 of the array, which kind of scroll off the screen a little bit already, but that's column G, which has a value of 14. So that 14 does equal to the 14 of K, which is column N. So that means when we ask whether they're different, the answer is false. So true and false is false. And this is when we exit the loop and get on to line 13. So this is when we get to line 13. All right. So when we end up on line 13 says, evaluate B is less than or equal to E. B is 4, E is also 4. 4 is less than or equal to 4 is true. So we are returning a value of true in this case. So what do we do when we return? Look up the rightmost column that is return info, change the question mark to the value that we're returning, right? So we just look it up. It's column K, okay? Copy and paste it. Change the question mark to the value that we are returning, which is false, which is true, sorry. It is true. And then we kind of scroll down a little bit. You'll go to the skip one row, and then in column B, we just say, okay, you'll just copy this over so that we know what to do when we get to that point. And now we have a whole bunch of stuff to deallocate because we have these three to deallocate. So we'll kind of handle these three first. Okay. And then we also have these three to deallocate because all the local variables, along with the parameters and the return info, they all get deallocated at the same time. So this time we have all of these columns to deallocate. Alt Shift 5. And by the way, on the Mac, it is a different keyboard shortcut. So you kind of have to look it up, to find out what is the shortcut on the Mac. But regardless, we are now continuing execution on line 19, which is over here. But because we have already called bin search successfully, it returned a value of true. So that means, oh, okay, we are just going to change the local variable result to true. So we look it up and go like, okay, the rightmost column that is labeled result is column J. So column J is the one that is now changed to a value of true. We then move on to line 20, which is a return 0 in main, which also means we are pretty much done at this point. So do we have any questions about this particular trace? It's kind of like a combination of things that we talked about last week, which is passing an array as a parameter, and the things that we talked about before last week, which is the search algorithms. One is called linear search and the other one is called binary search. So it's kind of like a combination of those two. All right. So are we doing okay so far? Any questions? We're good? All right. Excellent. Cool. And well, I was pretty close. Okay. I said it will take about half a class to talk about this. It is almost exactly one half of the class. So that's just intuitive. It's just me looking at this and go like, yeah, intuitively, this is kind of how long it takes. All right. So let me just give you guys one more chance to ask any questions about the trace or the algorithm of binary search as an iterative function, which iterative means it has a loop and not recursive. So do we have any questions? Do we understand all the mechanisms involved in here? Okay, all right. So if this is done, then we're going to write a new program, okay, to trace. So we'll go ahead and make sure that I can close this, but then I'm going to copy and paste the code, all the way to this side so that we can have the actual algorithm in place here, or I can just copy the code. Either way works. I think I'll just kind of copy the code. Okay. Yeah, that'll work. Um, and then just kind of put it over here, like so. I mean, oh, that's ugly. I don't like that because the indentation is gone, so I don't like it. If that is ugly, we're just gonna take a look at this and just take a screenshot like usual, and then paste it into the spreadsheet. There we go. All right, so we're done with this one. So now we're gonna look at a new algorithm. Okay, so we'll go ahead and take a look at, I'll just call this sum.cpp. So we'll start with main. Okay, so main is kind of the usual thing, int values. Again, it is an array and it has the following values. This time it doesn't have to be sorted. Okay, I'm just not doing the same thing anymore. Okay, so we'll just have four, that's fine. And then we'll have, int sum. I'll call result. Okay, it is an integer this time. So result is the value of being of summing, and we're going to pass the values as the first argument, and we're going to pass the number of elements as the second one, which is a 4 this time. And the first one, the first index is a 0. So we'll just pass a 0 here. And then we go back. Oh, wait, I have to say return 0 here. And now we go back and define sum as a function. So int sum, the first argument or the first parameter is called a, just like before. The second one is n, just like before. The third one, I'm going to call that I. And the sum is going to do the following. Um, I'm just thinking whether to do it as a ternary expression or as a conditional statement. We'll do a conditional statement. So we'll say if n and I are not are the same, or if I is greater than or equal to n, then do nothing except to return the value of 0. Otherwise, it is going to. So this one is just your programming style or how you want to kind of stack up the braces and the words. Some people like to do it this way, so you don't have you're basically combining three lines into one, because other people would put the else on the second line and then the open brace on yet the next line instead of just line 4. I think this is more concise, still get the message across so that we can still clearly see which one is the then portion, which is line 3, and which portion is the else portion, which is line 5 at this point. So I think this is fine, okay? But you guys can choose however you want to do the spacing, where you want to put the open brace and the close brace. So that's you have options there. All right. So in this case, we're going to return. Okay. So what we know at this point is I is less than n. Okay. Let me repeat the statement that I just said. On line 5, we know for sure one thing, which is I is less than n. Is that okay? Okay. And if we also make the assumption that that I has to be greater than or equal to 0 because of the way we call sum, that means I is a valid index into the array at of which a is pointing to. Oof, okay, that's a statement. So we know that we can at least access a bracket I as an element. Okay, it is valid as an element. But we are going to go like, what about the rest? Well, if we have to handle the rest, we're going to call the function again. We have function a again, which also has just n elements, but the index is going to increment by 1. So we're going to have I plus 1 here. So I'm doing this recursively. There we go. All right. So we'll go ahead and save this program and then use GDB to run it a little bit just to make sure that it does work. So G++ sum dash G dash O sum.cpp GDB sum, list the program, put a breakpoint on line 13, run the program, and now we have to manually add up all these values. 4 plus 6 plus 4 is a 10, 10 plus 10 is a 20, 20 plus 22 is 20 plus 2 is 22. There we go. So now we think a result should be 22, and it is. Okay, so we know the algorithm works. Okay, it compiles, it works. So now the question is, how does it work? How does it get the job done? So we'll go ahead and take a look at that. Okay, so we'll quit in the debugger and just kind of go back to the editor so that we can take a screenshot. Yes, yeah. So the function sum is just adding the elements starting with element I and then the rest. So that's essentially what it does. But in main, it says, okay, let's add up all the elements starting from element 0. So that basically the entire array. Yep. All right. So what we'll do is we are now just going to take a screenshot as usual. Okay. But this is just for display purposes. Later on, we're going to make another screenshot, just to add it to the code. So this time we just want to open it so that we can see it. Um, yeah, that's There we go. Go back to this one. Make it always on top. I'm just gonna move it over here. All right, there we go. So this one is going to be quite a wide trace because we have to do the recursive thing, and there will be five invocations of sum, when we're at the very end. So it's going to take up a lot of columns. Okay, so it might look a little bit confusing, but it's not going to be too bad, I hope. A lot of it is really just repetitions. So we start on line 9, doesn't do a single thing. Then we get to line 10. We allocate a bunch of columns for values. There are four columns this time. 0, 1, 2, 3 are the elements. And then the values of those elements are 6, 4, 10, and 2, respectively. And then we move on to line 11. We now have a local variable called result, which has an unknown value to begin with. And all of these columns can shrink a little bit. There we go. And now we move on to line 12. So line 12 says, okay, I need to call the function called sum. When it comes back, I still got things to do on the same line. So that means we need a return info to go back to line 12 to finish up, result equals to whatever the function is returning, which is now using a placeholder of a question mark. And then we have to set up all the columns for the function call itself, which, like the previous one, sort of, it has got a, it has got n, and this time it has got I. A is still the same thing. Okay, I haven't fixed this one yet. Give me a second to make it look nicer. Okay, so this is not really functionally important. It's just making things look a little bit nicer. There we go. So now it looks nicer. Okay, so just like in the previous program, A is a parameter that is receiving an array. And in C++, all it can do is to say, oh, if you're asking me for an array, I can tell you where to find the first thing. That's all I can tell you. Okay, so that's all it can do. N is the second parameter, which is now matching the second argument, which is a 4. And then I is matching the third argument, which is a 0. So now we got all the columns all set up. This time we do not have any local variables. So actually, it's not quite as horrendous as I think it would be, but it's still going to take up a lot of columns. All right. So now with all the columns set up, we go to the first line of the function, which is on line 1. And then it doesn't do a single thing. We go to line 2, which asks the question, I is greater than or equal to n is, it is false, right? Yep. Okay. So this is false. And then where do we go? We go to 4 or 5, but since line 4 doesn't do a single thing, we go to line 5. Yeah, so we go to line 5, and line 5 says, I really want to do a return, but I don't know what to return yet. Okay, because in order for line 5 to return a particular value, it has to be first able to evaluate the addition. The left-hand side of the addition is not a problem. We know what A is, we know what I is, but the right-hand side is a problem because it says it's a function call. So that means, okay, so now we have to say, okay, we need a function call to sum, which has, A and I as its parameters. The return info says I have to go back to line 5 because I got unfinished business on line 5, which is returning whatever the return value is to A bracket I and then return that. So are we good so far with how the return info is set up? Okay, cool. So A is, so the A that is already existing, which is column I, which is a reference of column C, is used to set up the new A, which is also just a reference to column C. N is passed as it is. In other words, this N here is just passed by value to this N over here. So when we set up the new column N, which is also at column N itself, it is a 4. I is the only one that got changed. So when we look at I plus 1, the I in the I plus 1 is looking at the column that is labeled I that is already here with a value, which is column K. Column K has a value of 0, so 0 plus 1 is a 1. So that's how we set up the second invocation. All right. And then we go to line one again. We get to line two. I is a little bit better than last time. It is a one, but one is greater than or equal to four is still false. So now we get to line five again. So this time when we get to line five, we kind of go like, it's going to be about the same thing. Yep, it is. So it's about the same thing with only one minor difference. The one minor difference is I. So this time I does not have a value of 1 anymore. It now has a value of 2. Okay. All right. So let's see what this is going to do. I'm going to maximize this. Okay. And push this over here first. I just need to shrink the columns because otherwise we can't see everything. All right. There we go. So now we get back to, guess what? Line one again. We get to line two. I is now a two. Two is greater than or equal to four is false. So we get to line five again. Okay. So this one is really kind of a lot of repetition. Okay. So there we go. We look up these four. Okay. So I'm getting a little bit lazy. Okay. Just kind of copy and paste and then change the two to a three this time. Huh? You're correct. Yep. All right. So let's move these. Okay. Control X, Control V. There we go. Thank you. All right, so now we shrink the four columns, or just this is just formatting, making it look nicer. I mean, it doesn't do anything that is functional, which is okay. All right, so now we get back to guess what? Line one more time. Okay, and then we get to line two. Line two. This is I. I is now three, but three is greater than or equal to four. It's still false. So we have one more invocation. Okay, so we copy and paste this again, and this is on row 24. So I think this is the right place. Paste, and then we have to kind of do some formatting again. So we just look at these four, kind of shrink it a little bit, like so. And now it's a little bit harder to read now. I can do a little trick here to make it a little bit easier to read. Okay, so I can now scroll the other side without scrolling both sides. All right, so now we get to I have to look up the rows to make sure they're lined up. So we get to line one again, but this time when we get to line two, um, n the rightmost n or the rightmost column that is labeled n is column Z this time. It has a value of 4. Okay, so 4 is greater than or equal to 4 is finally true. Whew. And what do we do? Well, according to the algorithm, we have hmm, um column Z is Oh, I have to change it. You're correct. I forgot to change that one. Thank you. Yep. All right. So now we get to um okay, so the condition is true, so that means we go to line 3. Okay, so we go to line 3. Line 3 says, all right, look at all the columns, find the rightmost column that is labeled return info, and then change that question mark to a 0. Okay, because we are executing line 3, which means the return value is 0. Okay, so we look up the rightmost column that is labeled return info. Turns out to be column X this time. Copy and paste. Okay, copy, paste, change the question mark to the value that we are returning, which is a 0. And then we skip one row. And then we say, okay, when we get back to line 5, this is what we need to do. So at this time, we no longer need the columns over here. So now we are deallocating these 4 columns. Okay, mark them as struck out. And now we are continuing our execution on line 5. So that we are now back on line 5. You go like, okay, we're back on line 5, but what is the context? What is the A and what is the I? Well, we are looking at the rightmost column that is labeled A. which is column S, and then we are looking at I, which is STU. So I would be in column U. So that means we're looking at the the last element of the array. Okay, so I have to scroll a little bit here. So now we're looking at this 2. So it becomes a 2 plus 0. So that means your line 5 is essentially returning 2 plus 0, which is returning a value of 2. So what do? Well, we look up the rightmost column that is labeled return info. This column is gone, so it would be up to this column now. So we look up this column, we copy and paste it. I have to line up the rows. At this time, it's returning a value of 2. Is that okay? So once again, this is the really confusing part because, okay, let me move this thing out of the way. We can just kind of stash it here. So we are looking at column T. So column T provides us with what we need to tweak, but we are executing what is in column B. So column B, row 30, is telling us what we need to do. Okay, we are returning 2 plus 0, which is a value of 2. But whenever you execute a return statement, you need to locate the return info cell and change it. Well, that turns out to be column T. So that's why we copy column T, change the question mark to the value that we're returning, which is a 2. That is how we deal with this execution. Okay. So I know this is probably the most confusing part of tracing this kind of code. Okay. Um, Last week we did a little bit of this already, so we I want to keep doing this a little bit, okay, until you guys have are used to it and don't have any questions. Okay. Okay. And then what do we do? Well, we skip one row and then we say, okay, when we get back to line 5, this is what we need to do. Okay. So now we have no use of column T all the way to column W. So we just copy and paste it, striking them, or strike them out. And now we are back to line 5 again. So every time we get back to line 5, the columns that that line 5 is referring to changes. That is the most important part also to understand is when we get back to line 5, this time on row 32, we are no longer using column T to column W as our context. We are now using column P to column S as our context. So that is the most important part. So when we look at row 32, the A is referring to the rightmost column that is labeled A, and we column Q this time. Now, you might say that, oh, but all the columns labeled A are referring to references. They're all referencing column C. Yes, they are like that in this code, but that's not necessarily true for all the programs. Okay. But the other part, which is I, is definitely not the same, right? So because this time on row 32, the I is referring to the rightmost column that is labeled I, which is column S, which has a value of 2. The other ones all have different values. All the columns labeled I have different values. All right. So now this time we are looking at element 2 of the array that starts at column C. Okay, let's look it up. That has a value of 10. Okay, very good. So what we're going to do is now just to look up the rightmost return info cell, which is now column P, right? Copy and paste it. Okay, we'll paste it over here and um, change the question mark to 10. That is correct. No, no, we are not changing that to 10. We are changing it to whatever the sum is returning. Okay, so I am a little. The A of I is 10, so 10 plus 2 is a 12. Yep. So we're changing the question mark to a 12. There we go. There you go. So once again, this is what we are evaluating, or column B, row 32. that is telling us what we're doing right now. So a bracket I, we just looked it up, is a 10. 10 plus 2 is a 12. So that means 12, 10 plus 2, 12 is our return value. So that means now we have to look up column P, which is because it's the rightmost return info cell, copy and paste it, and change the question mark itself to the value that we are returning, which is 12. Okay, very good. Okay, so you're getting it. Good job. All right, so we do basically the same thing, which is skip one row and say, okay, when we get back to line 5, this is what we're going to do now. Okay, so now we don't have use for column P to column S anymore. So we just deallocate those over here, and now we continue execution again on line 5. But you can now see that every time, quote unquote, we return to line 5, the function call itself resolves to a different value. Okay, so that's how we are unwinding recursion. This is called unwinding. So if you imagine that when we are moving to the right hand side, when in terms of consuming the columns, that's winding up a toy. Okay, you're basically cranking that spring, and now we are quote unquote relaxing, and so the spring is unwinding. Okay, so that's kind of what we are doing. Okay, so now we're executing um, B34 as a cell. Okay, we have to look up what is A bracket I and then add 12 to that value. That sum becomes our return value. So now we look up, okay, who has the rightmost column that is labeled I? Okay, and that turns out to be column O, which has a value of 1, and then um, element 1 of the array starting at column C has a value of 4. So the whole thing becomes 4 plus 12, which is 16. So we are returning a value of 16. So when we do that, we have to look up the rightmost column that is labeled return info. And now it is column L because all the other ones are deallocated. So now we just make a full copy of that, change the question mark to 16 because it is 4 plus 12. And now, we will skip one cell on column B and then say equal to this, or you can hand copy, in on a piece of paper. And now we deallocate columns L to O. So this time I'm just going to do this kind of a little bit lazier work right here. There we go. And now we're back to line 5 again. But this time when we get back to line 5, you can see how the right-hand side of the addition is now changed to 16, and then the references of A and I are both changed. So in other words, they're now referencing the earlier parts of this code. So let me just kind of use this trick here because that makes it a lot easier to read when we get to this point. So because all of these columns are deallocated, everything from L all the way to the right-hand side, they're all deallocated. So this A is referring to column I, which is the same, okay, referencing column C as the first column of the array that we need to access. The element that we want to access is I. The rightmost column that is labeled I is now column K, which has a value of 0. So A bracket I resolves to A bracket 0, which is the first element. It has a value of 6. 6 plus 16 is 22. So we are returning a value of 22. So when we execute return 22, we look up the rightmost column, which is column H that is labeled return info. Okay, copy and paste it, change the question mark to the value that we are returning, which in this case is 22. And then we skip one row, okay, just to keep track of so that we can deallocate the columns. But now we just reference the changed cell, okay, with the question mark changed. And now we can deallocate those four columns. So look at these, we just deallocate those. Now we're back to line 12. Line 12 says, okay, the rightmost column that is labeled result, let's change that to 22. That's column G. So we just go to column G, change that to 22. Then we move on to line 13. Line 13 is a return 0. So we are done at that point. All right. So we have been doing something similar to this for a while. Okay. The The previous homework assignment, was kind of like this. Okay, so I just want to make sure that as we practice more, okay, and when I disclose the solution to the homework assignments, you guys can get a chance to look at your trace, look at my trace. If it's only different because I traced the else line, or the open brace line, that's okay. That's not a problem. Okay. But if it is different in terms of how we change the return info cell and stuff like that, that is different. Okay, that is important. That's significant. All right. So do we have any questions about the trace of this particular program? Okay. Okay. Yep. hmm Yeah. So it helps, because everything is being recorded, I hope. Yes. Sometimes I forget. But because everything is recorded, it means you can watch this whole thing again. But when you watch it again, that gives you time to pause, right? You pause and then you jot down the notes. And the best thing is you can make a copy of this entire spreadsheet and then you annotate the cells and go like, okay, now I understand what is going on here. Column B is the statement that I'm executing. It provides the value that I need to return. But whatever column that is labeled return info, elsewhere, that is the thing that you're modifying. It might look even almost exactly the same as the statement that you're executing in column B. It doesn't matter, okay? Your only job is to copy and paste it and change the question mark to whatever the statement in column B is asking you to change to. That's it, right? You just keep it that way, and then you skip one row, and then you copy that return info cell to the next row in column B as a reminder of, okay, this is the next step. This is what I need to do next, and then you deallocate the columns. So you can write down all of those steps in your own words inside the spreadsheet. So that way you have a record now of where in the spreadsheet what we are doing. Yep. You don't need something as complicated as this. I mean, if your own array only has like two elements, it will still kind of demonstrate exactly the same thing, but it won't show you the shape of the trace as well as this one. So if I just kind of get rid of all these things, okay, I'll put this one back here. Uh, this is column B. Okay, it kind of needs its own space. There we go. Okay. So I'm gonna zoom out all the way because I just want to show you the shape. So if I zoom all the way out, look at the shape. It has a particular way to it, right? So to print this out may not be very easy because you might have to shrink the font a little bit before it would fit onto the same page. But you can look at the shape, okay? The shape is what is important. When we do recursion, whenever we call, we are growing to the right hand side. Whenever we return, we're shrinking to the left hand side. Okay, so let me print. Oh, actually, it all fits in one page. Nice. It just so happens that everything fits on one page in this case. Yeah, I think it's kind of cool. Yeah. So yeah, go ahead. Yeah, outside of this class, when you take CISP 360, 400, 430, they will still be using C++ code, but they won't be tracing the code the way that we do here. So this is basically the only class where we really, really look at what is happening behind the scenes when we execute C++ statements. The only other class where you actually see the stuff behind the scenes, not exactly the same way that we do here, but in a way that actually explains the mechanical aspect of what goes on inside the computer, inside the processor, would be CISP 310, which you can take next the semester after 360. Yep. All right. So I'm gonna end the lecture, just because, without the whole class here, things go. faster, which is not necessarily a good thing. Because I think that's the value of being in class, in person, is you can ask questions right away, and I can see whether you guys understand, the concept or not. If you don't, we can slow down. I can try to explain things in a different way. But if it is recorded, I don't know that people are not quite understanding, what I'm trying to say, and go like, okay, if this is not working, let's try a different way. Yep. All right. So I will let you guys go. Okay. I'm gonna stop the recording and then upload it. And then the spreadsheet is already there. Okay. The moment I create the spreadsheet, you guys can access it right away. Yep. Yep. See you on Wednesday. And Wednesday we're not gonna talk about this. We'll be talking about the practice exam from last semester. Yep. All right. Hmm? Next Wednesday. Yep. Yep. See you later.